Good morning, everybody. Now, this is our last lecture of steel structure, and almost we have completed 5 chapters of steel structure. In previous lecture, we have studied about the analysis of compression member. Now, we are going to discuss about the design of column as a compression member. So, in this design, there is some minor thing is added in our previous lecture. Let's see. Design a steel column to carry a factored axial load of 1500 kilonewton. The length of column is 3.6 meter and hinged at both ends. Fy is 250. Now here we have a load that is 1500, which is factored load. First of all, we have to finding out the required area, and for that we have FCD, but that not given in this case. So we have to first assume our FCD, and it is 0.6 Fy. So it is 150 Newton per mm square. The important things over here, that is FCD value may be assumed between 0.4 Fy to 0.6 Fy. For a rolled section, if length of column is less than 5 meter, then FCD must be 0.6 into Fy. And for built up column, again it is 0.6 into Fy. So here in this case we have length that is 3.6 meter. See over here. So we must have to assume FCD is equal to 0.6 Fy. That's why it is 150. Now we have to finding out the required area, and that area required is equal to P upon FCD. This is our equation that given on page number 34 IS 800. So from here we will get the required area, that is 10,000 mm square. So it is almost 100 centimeter square. Now from this required area we must have to choose a section from steel table which is having the area nearby 100 centimeters square. So from steel table we will get choose a section ISHB 400 at the rate 77.4 kg per meter, and area of this is equal to 9866 mm square. Height is equal to 400 mm, BF is equal to 250, so B is equal to half of this 125, thickness of flange 12.7, thickness of web 9.1. These are the important properties of that section. Again, root radius, that is 14, RZZ and RYY, both property must be taken from steel table. Now, as we know, first we have to classify our section, and the section classification is given on page number 18 IS 800. The section, that is epsilon is equal to 250 upon Fy raised to 0.5. Now flange is equal to B upon TF, that is 125 upon 12.7, so it is 9.84, which is less than 10.5 E, that is epsilon. So our flange is incompact. Now web, D upon TW, and we know that 400 minus 2 into 12.7 minus 2 into 14 upon 9.1, so it is 38.8, and which is less than 42 epsilon, so it is semi-compact. So our whole section, that is semi-compact. Now AG is equal to A, that is 9866 mm square. The first step is over here, and The effective length now we have to finding out, and the effective length must be taken from page number 45 IS 800, and there we have the condition that both the end of the column are hinged. So the KL is equal to 1 into length, so it is 3600 mm. Now buckling class, that is given on page number 44. So first we have to choose our buckling class for this section. So H upon BF, which is greater than 1.2, and the thickness of flange, which is less than. From these two criteria we will get the buckling class about YY is used as a curve B, since the RYY is minimum for column failure, that we know, and we have taken this kind of number of example. Now KL upon R is equal to 68.44, which is less than 180, that's why it is okay. Now from this KL upon R we will get the FCD for the class B, and which is given on page number 41. So FCD is equal to 168.34. Now we can calculate the design compressive strength for this, and that is PD is equal to A into FCD. So the design compressive strength PD is equal to A into FCD, that's why PD is equal to 9866 into 168.34. So 166,0842 kilonewton, and so we will get that is 1660.84 kilonewton, which is greater than 1500. So it is okay. Now we can provide the section which is satisfy our all the conditions. So this taken section is okay and safe for the column. These kind of examples are mostly used in actual practice. Now another case, what they have given over here: design a column to carry an axial load of 1000 kilonewton. The column has an effective length 6 meter with respect to ZZ about 6 meter and 4 meter with respect to y axis. Here we have effective length in both the directions are different, and that is depending on our connection. Here FE is 410. Now P is given, that is factored. Assume FCD is equal to 0.6 into Fy. AG required, the same thing repeated over here. So P upon FCD, it gives us the required area, that is 66.66 centimeter square. Now choose this section from steel table. So we have chosen over here, that is ISHB 250. Now the property from the steel table, that is area 6971 mm square, RZZ 107, RYY 53, BF is equal to 250, so B is equal to half of that. Thickness of flange 9.3, thickness of web 8.8, H height, that is 250 mm, root radius, that is 10 mm. Now from this we are going to classify the section and design the section. Now section classification, which is first we have to finding out the epsilon. So it is 1 over here. Flange is equal to B upon TF, that is 125/9, so it is less than 15 points. So the flange is in semi-compact. Now web D upon TW, that is 250 minus 2 into 9.7 minus 2 into 10, so it is 8.8, which is less than 42 epsilon. So again it is semi-compact, so our whole section lies in semi-compact. So AG is equal to 6971 mm square. Now the effective length here for the both axis is different, about Z and about Y. It is about Z axis it is 6000 mm, and about Y axis it is 4000 mm. Now buckling classification, that is H upon BF, that is 1, which is less than 1.2, thickness less than 100 mm. So from the page number 44 we can identify our two curve. For the ZZ axis it is B and about YY axis it is C. So KL upon RZZ it is 56.07 and KL upon RYY that is 74.48. Now here we have both the slenderness ratio about different axes are different. Now since the slenderness ratio about YY is higher, failure will be due to buckling class about YY axis. So strength about YY axis will be lesser. Now buckling about YY axis, that is C class. So KL upon RYY is equal to 74.48. So we will get FCD, that is 144.83 from page number 42 ISO 800. Now from this FCD we can calculate the PD, and that PD is equal to A into FCD. So 6971 multiply with 144.83. So we will get 1009.61 kilonewton, which is greater than 1000 kilonewton. So here we have taken that section that is okay in all the aspects. That's why the chosen section is okay. So we can provide ISHB 250 as a column for a particular this case. So this is the simple method. If once you know about the analysis, then you can design the section. There is a minor change. In analysis we have section and we have to just analyze that. But here first we have to choose the section, and for that we have to finding out the required area, and for that we have just calculate two different step more as compared to analysis. Clear? Good. Now again we are going to take some different case. Design a column to carry an axial factor load of 1200 kilonewton. The actual length of the column is 6 meter with both ends effectively held in position, and restrain again rotation. Select two channel back to back. Assume that the column is laced. This is the different case. Here what they have called us, take two channel back to back. We have to choose, and lacing is provided there. That is the different thing. It is calculated as per the IS code, but the criteria for the choosing that section is little bit different. So let's say first P that they have given, that is 1200 for a built up column. FCD is equal to 0.6 into Fy, that we know. So required area for this FCD 150, that is 1200 into 10 raised to 3 divided by 150. So 80 centimeter square area required. So from steel table they have given us the two channel back to back, two channel toe to toe. So from that we have to choose two ISLC 250 back to back from steel table, and area of that is 7130 mm square. Now we have to take RZZ for that and RYY for that. We must have to take this section in a way that these two radius of gyration must be nearly equal, and spacing for that there is 140 mm. Now select back to back spacing such that RZZ and RYY must be equal. So it will be give most economical section. Now R minimum is equal to 102.2 mm. Now effective length that is KL. So here the both ends are restrained against rotation. So we have to take, it is fixed at the both ends. Now KL is equal to 3900 Nm from this. Now for a built up section, always the buckling class C will be selected for this section. So KL upon R, it is 38 point. So, but here KL upon R for a built up column, it is increased by 5%. So it is 1.05, which is less than 180. That's why it is okay. Now FCD for this 197.33 Newton per mm square. So PD is equal to AE into FCD. That's why it is 7310 into 197.33. So it is 1442.48 kilonewton, which is greater than 1200 kilonewton. So the selected 2 ISMC section is suitable for our design. Now, dear student, whenever we are going to design, we must have to sketch the section. So it is very much useful for us. Now here this is 2 channel ISLC 250 back to back with spacing 140 mm. This is centroidal axis, and this dotted line gives us the lacing. What is the lacing? Whenever you are visited the railway station, there is a column, laced column are there. It is inclined strip of that steel plate. It is connected with column something like that, zigzag way. That is seen by you, but now you can Google it. So here in this chapter we have studied 4 major things. First, analysis of strut, then design of strut, then analysis of column, and design of column. So all the 4 type of examples are completed over here. Now from this, this chapter of steel compression member is over here. Now dear student, we have studied here 5 chapter, and that is most important. Whenever we are talking about the एग्ज़ाम में आपको आरसीसी एंड स्टील दोनों का 35 मार्क्स का आएगा. उसमें से मेजरली अराउंड 40 मार्क्स आरसीसी का आएगा एंड 30 मार्क्स का स्टील आएगा. स्टील में ये 5 चैप्टर जो है दैट इज मोस्ट इम्पोर्टेंट. उसमें से ऑलमोस्ट आपका 30 मार्क्स का कंप्लीट हो जाएगा. रिमेनिंग जो है वो ऑप्शन में निकल जाएगा. सो इट्स माय रिक्वेस्ट टू ऑल ऑफ यू, आप सबको सिर्फ ये 5 चैप्टर्स ही करने हैं. बाकी का जो चैप्टर है लेसिंग वाला, अगर आप इंसिस्ट करोगे तो मैं आपको समझा दूंगा, बट 5 चैप्टर ही आप कंप्लीट करो. एंड दिस इज यूजफुल फॉर आवर नेक्स्ट subject also. Up to here no need to do anything, but this is most important 5 chapter for us. Now I have declared this syllabus for you up to 5 chapter is completed over here. Now whenever you demand, we will discuss another chapter, but till then you just concentrate on this 5 chapter. Clear? So we have studied first introduction of steel, that is most important. Now उसके बाद हमने क्या देखा? वोल्टेड कनेक्शन, उसमें भी एनालिसिस एंड डिज़ाइन. वेल्डेड कनेक्शन वो भी हमने देखा. फिर टेंशन मेंबर, उसमें भी एनालिसिस डिज़ाइन. कॉलम में भी हमने एनालिसिस ऑफ स्ट्रट, डिज़ाइन ऑफ स्ट्रट, एनालिसिस ऑफ कॉलम, डिज़ाइन ऑफ कॉलम, सब देख लें. दिस इज मोर देन इनफ फॉर यू. ओके फाइन। तो आपको इतने चैप्टर्स अभी करने हैं, इसमें से ही मेजरली स्टील में आता है एग्जाम में। ओके, थैंक यू वेरी मच।